All right, okay, so there it is. So they want you to do the difference quotient for that thing. So go ahead and give that a try. So it's done in pieces, right? I think, did we start one of the pieces, I think? So you got to keep going. So in other words, I'm just going to do the f of x plus h piece first, right? There's different pieces. There's the f of x plus h, then there's the f of x, then there's the h on the bottom. Kind of like breaking it into three pieces, you know? The hardest part is the f of x plus h. So that just means take the function, here's the function, and just plug x plus h in everywhere you've got x, huh? So that'll be x plus h squared minus 4 x plus h plus 7. So clean that up and then put that together with everything else. See if you know how to do that. I'll run through roll and finish that up after this. So, and I didn't do roll last time, did I? So where are we? I think we're here. Second, fourth. Something like that. All right. Rania is here. And Victoria is here. And Katharina is here, and Thea is here, and Emmanuel is here, and Gerswap is here, and Carlo is here, and William is here, and Eros is here, and Tanya is here, and Kelton is here. And Timothy Delberto is here, and Celeste Dominguez. Celeste? No Celeste? Okay, and Edgar is here, and Jessica, and Rongfu, and Raymond Garcia is here, and Martin Guadalupe is here, Seth Kisby is here, and Shadow Lee is here, Phoebe Lopez is here, and Mong Lor is here, Maravich is here, and Antonio Medina is here, and Isaiah Mendez, Isaiah here, okay, and Shane Maroff is here, Robert Nunez, Robert's here, oh, wait, and okay, and William Nelson, no? I'm over here. Oh, there you are. All right. And Juan Olia is here. And Sergio Ortega is not here. And Venita is here. And Tanya Ramirez is here, and Michael Rukaba is here, and Mohammed's here, and Christian's here, and Jorge is here, and Linda is here. Ana Iri's here, and Orlando is not here. No Orlando. And Vincent Tao is not here. Vincent Tao. And Destiny Valenzuela is here. And Diego Vargas is here. And Elisa Zong is here. And Richard Zong. Richard No. And Chu Yang is not here. No Chu Yang. And Fidel Zuniga is here, and Cheng Vang's here, and Samuel Zong is here, and Ivan Gonzalez is here, and Taras is here, and Malik is here, and Brianna Santos is here. All right, did I miss anybody? I don't think I did. All right, so you guys able to finish that one up okay?
For the H, you just stick it in for the X.
Do the what's that?
I said for the H, you just stick it in for the X.
Not just the H, the whole thing. Yeah, so the whole X plus H. So remember, when somebody gives you a function, they write f of X.
I meant the H alone, not the X plus H. I meant the lower part, what's being divided.
The H on the bottom is just H. It's not plugged into anything because there's no function notation next to it, right? It's not f of H. Notice, it's just H. Yeah, good question. Everybody see that? The bottom is just simply H. It's not f of H. So we're not plugging that H into anything. It's not being plugged into the toaster, right? Yeah, so the original function, x squared minus 4x plus 7, that function, we're plugging in x plus h, as we did right here, and then we're going to subtract. So this, well, in fact, let me kind of clean this up. Here, let me just, changing my whole mind. Let me just do this to make it nice. So first off, it's x plus h squared minus 4, x plus h plus 7, and then it's going to be minus f of x, which is x squared minus 4x plus 7, all over simple h. Yes, everybody see what happened there. So in other words, this is f of x, and this is, oops, I thought I changed my color there, is f of x plus h. Right, so there's f of x plus h minus f of x. I put parentheses around the f of x because I'm going to subtract the whole f of x, not just the front part of it, right? If you don't put parentheses, you're only going to subtract the front part. You got to subtract the whole thing, which means that minus has got to distribute, huh? You got to square. Now, remember again, it's common mistake is to say x squared plus h squared, but I've said it enough. You know that's not it, right? So it's going to be, if you FOIL that out, you're going to get x squared plus 2xh plus h squared, right? If you have, so make sure you can get that okay. Minus 4x minus 4h plus 7. And then comes the f of x stuff. The minus will distribute. Minus x squared plus 4x minus 7 over h. Good to there? Just multiplying all that mess out. It's like what you're going to start with in calculus. Oh, it's off the screen a little bit, isn't there? I don't know why it does that. Anyway, no, not helping at all. There's a minus 7 there at the back end. Here, let me squeeze that in a little bit better. So that's a plus 4x minus 7. Is that better? Yeah. Okay, so let me give you a hint. When you're doing this particular formula, every non-h will cancel on top. Every term that does not have an h, non-h, every term that doesn't have an h, it will cancel. So that's a good way to make sure you didn't make a small mistake. So for example, I'm looking at that, so I'm just going to cancel it out right now. There better be something to make it cancel. Sure enough, there is. Because why? Because it doesn't have an h. So I'm telling you, whenever you do the difference quotient, this thing is called the difference quotient because it's a subtraction, difference, and it's a quotient. It's a division. So, and now, the minus 4x doesn't have an h, so it better cancel out. Sure enough, there it goes. Positive 7 doesn't have an h. It better cancel out. Sure enough, there it goes. Notice all the non-h'ers canceled out. They always will. So it's a good way to make sure you're not making any small mistakes. All right, what are we left with? Can we gather any like terms? I don't think so. No. So just 2xh plus h squared minus 4h all over h, right? And then, you know what it does there? That h cancels an h from each of them, doesn't it? So that'll become 2x plus h minus 4. And that's the answer. We good on that? Questions I can answer? It canceled this h, one of these h's, and that h on that. Yeah?
So why do we use the difference quotient?
If you put the limit as h goes to 0 in the front, it's the derivative. It's the slope of the tangent line. It's the rate of change of a function. Calculus. So I'm just getting you ready with the mechanics. They'll tell you what it all means in the real world and things like that, if you don't already know. Questions on that one? We good? All right, let's try and do good with those. Okay. So here we go. So yeah, this is real tricky. They do some tricky stuff. So they're saying f of x equals 3x cubed plus ax squared plus 4x minus 1. And they're saying f of 2 is 7. F of 2 is 7. And they want me to find a. So basically, that means I can plug 2 into the function. Like that. And the answer should equal 7. Let me slow down there for a second. To see what just happened? F of 2, which is this, equals 7. That's what it says, f of 2 equals 7. See what I did there? I just plugged 2 in, and that should equal 7 because they told me it did. They said f of 2 is 7. So when you plug in 2, it's equal to 7. So that allows me to solve for a, huh? A is the only variable there. What is this? 3 times 8, 24. Plus 4a plus 8 minus 1 is 7. What's that? 32 minus 1, 31. 4a plus 31, if I did my numbers right there. And then subtract the 31. So 4a is something. What's that? 24? Minus 24? And then divide by the 4. That's a 31 right there. Right? And then that's negative 6. You can see that? Oh, it's off the screen. I don't know why the screen's different, but so it's negative 6 there. Let's put it right here. There we go. A is negative 6. Is that okay on that one? Everybody see what I did? I just plugged in that 2, and they told me it's going to equal 7, so I set it equal to 7 and solved. All right. All right. So they're saying express the area of a right triangle as a function of height. All right, so you guys know the formula for area probably, huh? If you don't, you can write it on your 3x5 card. Or the first exam, every exam, you get a 3x5 card, put anything you want on both sides. So anybody know what's the area of a triangle? Just the general, nothing fancy yet. Half base times height, yeah, have you seen that one? You know that one? Area of a triangle is half times base times height. That's for any triangle, that's true. Let's just start there. And now let's get a little more specific about what they're talking about. First off, they mentioned it's a right triangle. Kind of set that aside for a minute. And they say they want the right triangle, the area, as a function of height. Do you know what that means when somebody talks that way? When they say, I want this thing as a function of height. What that means is they want me to write A equals blah, 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 and have an H in there. OH being the only letter. Is that off the screen? Yeah, a little bit. You got to remember it. I don't know why it's not grabbing the right side of the screen. But anyway, they want H to be the only letter in there. That's what it means when something is a function of something. So let me just write that out more thoroughly. Because that's an important thing you want to know as you go forward in math. They'll do that a lot. A as a function of, is it on the screen? Yeah. H means A equals numbers and H as the only letter. So it means they want you to write A equals and a bunch of numbers and whatever, and H being the only letter. Notice they don't want this B. This is specifically what it means to us in this situation. Get rid of that B. Right now, the way I have it written, A is not just a function of H, it's a function of H and B. And they don't want the B. They want A to be only a function of H, H being the only letter. Okay, so that means somehow I need to plug in something for the B. What am I going to do? Well, right here it says what? Height is twice base. Right? Height is twice base. Now, what do I want to plug in for? b. So I got to solve for b there first, huh? Divide by 2. So b is h over 2. So then take the formula, a is a half bh, and take that and plug it in for b. So a is a half, and b is h over 2, and then there's h. Did you follow with all that? Now I've got it in terms of only h. You can clean that up if it bugs you. It's 1/4 h squared. Done. All right, the two 2's on the bottom. A 4. H times h squared. We good? Everybody see what I did there? Right, I started with the general form, the half bh. They told me height is twice base. Solved for b, plugged in for the b. Got the formula into only h. That's what it means to write area as a function of only h. H is the only letter. All right, that'll come up again in our work. All right, so there we go. So we got that graph. We're in section 2.2 now. And they want us to use the graph to find f of 8 and f of negative 8. So can you guys see that okay? Maybe I should have blown that up before I moved it over. So, this is negative 6, not negative 8. Anyway, f of 8, first off, f of 8. So how do we find f of 8? Yeah, do you see it's right there? Because the 8, f of 8, this is the x value, huh? It's x that's in the parentheses. So they're saying, hey, go to that graph, go over to where x is 8, and find the y value that goes with it. So it's equal to 6. This is the, let me just do it that way. Yeah, so the key thing you have to know, so this section is not going to have much like adding, subtracting, multiplying, dividing. There's not going to be many steps to do. In this section, it's mostly going to be just reading the answers right off the graph. So it's all about, can you speak function graph talk, you know? Do you know what they mean when they say, look at a graph and find f of 8? So the main thing, the key to reading graphs as they relate to functions is knowing what's in the parentheses is x, what comes out there is y, always. So that's the main thing. So if you look at it and go, oh, they're telling me x is 8, find the y value that goes with x is 8. What's right there? When x is 8, y is 6. Huh? It's that point right there. They're just giving it to me. So that one's easy enough. How about the next one? How about f of negative 6? Yeah, so again, it's when x is negative 6. What's the y value that goes with that? Yeah, it's right there, huh? 0. That's it? That's all they want. Well, actually, there's 5 parts remaining, huh? So I guess we better look at those other parts. But that's the first one. That's the kind of thing they're going to keep doing. All right, let me go back. Okay, so same graph, different question. Is f of 18 positive or negative? Well, again, when they ask f of 18, they're saying the x is 18. What the y value that comes out, is it positive or negative? That's what they're asking, right? So the parentheses is x, what comes out is y. So go over to the graph, find 18. Where's 18? Well, this is 16. This must be 18. This must be the point. Whoops, I can do it right there. That's the point. Over 18, down, looks like 2. Everybody see that? See how I found that location? Right? It's clearly going by 2's, isn't it? 2, 4, 6, 8, 10, 12, 14, 16, 18. So I go over to x18, right? Because what's in the parentheses is an x. Go over to x18, and then go down to the graph. You find the dot that's over 18. It looks like it's over 18 down 2. So the y value, for x18, the y value is negative, isn't it? Good on that? So it's just reading the graph, but it's not always that easy if you haven't done a bunch of it. All right, how often does the line x equals 5 intersect the graph? Well, the thing you need to know about the line x equals 5, you need to know, is that a horizontal line or is that a vertical line? You're You can't be unsure about that. I mean, you might be unsure, but somehow you got to get, because if you do that wrong, it's going to mess up so many things. And not only that, it's not the way I would naturally think to remember it. I would naturally think x is sideways, but that's a vertical line. So why? Because it's all the points who are over 5. All the points who have an x coordinate of 5. That's a vertical line. So when you think deeper, you're like, oh yeah, I guess it is a vertical line. It's all the points over 5. But my just knee-jerk reaction would be, oh, x is sideways. But I'd be wrong, and then it'll mess up tons of stuff. So I would probably write on my 3x5 card or do whatever it takes for you to know if you just have x equals a number in an equation, that's always vertical. If you just have y equals a number in a graphing situation, that's always a horizontal line. You know, somehow keep that straight, that there's, you know, vice versa the way you would think. So I have a dumb trick from a student told me about it years ago, and I've used it ever since. It's embarrassingly dumb, but it works. If you take the x and you erase the bottom of the x, what do you have? It's too dumb for you, isn't it? Sorry. It's a v for vertical. See, that's dumb, huh? But, you know, sometimes those things help. So, you know, because you can't mess this up, guys. You just can't mess this up. I've seen students mess this up. It decimates a lot of situations, just getting that wrong. Later, we'll do some fancier stuff, and we'll talk about that. If you get that wrong, like, everything is messed up in the problem. You can't get that wrong. You got to get to where it's never wrong, right? So that's why I give you dumb tricks. Now, so I'm going to do some kind of trick to help you think horizontal for the y. Because I would normally think y is up, down, you know, but it's horizontal. So you tell me, it's so dumb you could probably see it. What can you do with a y to make it look like an h to remember horizontal? Turn it upside down. Right, you got it. It sort of looks like an h. All right, there's the dumb tricks. I'm embarrassed to be saying that in college, but if that helps you, there you go. No, I'm not. It's no help is beneath me. Yeah, Robert.
One of the tricks that helped me remember was I used to like to just circle the number and then draw a little arrow to the variable and say that the line crosses this axis.
Oh yeah, good. That's a good way. Just think axis, huh?
Yeah.
So like when you got x equals, it's crossing the x-axis. Nice. I like that. That's good. So x is 5. Yeah, right on. So it crosses at 5. So where is that? That's about right here, isn't it? Right, because those jumps are 2 each. Right. So it's between the second and third jump. Right. It's 2, 4, 6. So 5 is crosses the x-axis. Good way to say that too. So right there. So there's the line x equals 5. So how often does the line x equals 5 intersect the graph? Well, only once. You know, right there. Right? Once. One time. So after all that talk. Okay, so what do you guys think? For what values of x does f of x equal 6? So write f of x equals 6. Remember, this is clearly an x, and this is a y. Right? So they're asking for the x when y is 6. That's what they're really saying, huh? Because that's the y in the essence. So where's y 6 on the graph? Right there and right there, huh? Both have a y value 6, so the x's can be 0 or 8. The x's that go with y6 are 0 in one case and 8 in the other case. Good? So it's easy once you know what they're talking about, huh? It's just all about speaking their language. So domain is what? Domain of f. What does domain always mean? Well, I've said it a couple of ways. Domain, well, let me write it over here. Domain is possible or allowable x values. I've said, you know, it's what you can put in the toaster. You shouldn't put knives in the toaster. That's true. That's one way to say it. When it comes to a graph, possible x values, well, the x-axis is the sideways axis, huh? So the possible x values would be all the x values from here all the way to here. That's the domain. The domain is the width of the graph because that's the possible x values, huh? That's the x values it covers. It's the width of the graph. So it's the left edge to the right edge of the graph. So, and they want, notice, interval notation. So I'm going to go left edge, comma right edge. And with parentheses or brackets, it looks like brackets because Why? Because these are solid dots on the edges, right? It hits solid at those points, so it brackets straight on those dots. So what's the left edge? Negative 12, right here. And the right edge, 22. There is the domain of the graph. It's the width, left edge to right edge. And then the next question they're going to ask me is, what's the range? Let's just do that right now. The range is the up-down, huh? I'm going to write it here. Range. So the range is the up-down. The range is bottom, comma, top. Instead of left-right, it's bottom, comma, top. Range is up-down. Range is the y's. So what's the bottom? What's the lowest low that graph reaches? Yeah, it looks like negative 6 right here. Not quite, it goes below the negative 4. I'm looking at y values now for range. Y values, negative 6 is the lowest y value, a little bit lower than negative 4. And the highest y value? 8. Looks like that 8 up there, huh? The highest, again, y value. So that 8 right there. So it looks like the range is, what was it, negative 6 to positive 8. That's the range. On the screen barely? Okay. That's the range. Questions on domain and range? Domain is the width, range is the height. Domain is left edge, right edge. Range is bottom, top. Interval notation. I should skip, but I'll do it anyway. So, all right. So remember the vertical line test? If any vertical line, perfectly vertical, that doesn't look too perfectly vertical, but if any perfectly vertical line hits more than 1 point, right? Vertical line test. If any vertical line hits more than 1 point, then it's not a function. So this one is no, because there's a vertical line hitting 2 points of the graph. Do you realize that's just the graphical version of that same function rule I wrote out? Remember, what was the function rule? The function rule, when I wrote it out in words, was x, or input, goes to, to only one y, huh? To only, it's on the screen, one y. So x goes to only one y. That's the same thing, right? Because if you hit, a vertical line hits 2 points, what that means is that's the same x. I don't even know what that x is. It looks like it's over 2 or whatever. Maybe it's 4, whatever. It's over something. Up, I don't know, 4 and down 4. See how that's the same x going to 2 different y's, whatever the numbers are. If a vertical line hits 2 points, that's the same x going to 2 different y's, isn't it? So the vertical line test is just a graphical way of saying the same thing that the function rule is saying, isn't it? Vertical line can't hit 2 points. If it does, it's not a function. It's a picture, it's a relationship, it's something we can sometimes do stuff with, but it's not a function. And we're into things being a function. We'll see more why that is in other settings. But for now, it's not a function, although it's a relation. Okay, so that's it for that question. Myself lost here. Okay, so there we go. So we are looking, first off, is this one a function? Yeah, every vertical line hits only 1 point, huh? So yes, it's a function, first off. Passes the vertical line test. There's no vertical lines hitting 2 points. Okay, so next, find the domain and the range. Okay, the domain is the sideways. Left edge, comma right edge. So what's the left edge of that thing? Negative pi to positive, or regular pi. The range is the vertical. Okay, so it's the bottom on the screen, comma top. Okay, so what's the range? What's the bottom? Oh, that's easy. Negative 1 to 1, huh? They're right there on the graph for you. Negative 1 to 1. So we got domain and range. That was easy. Intercepts. This, and this. Those 3 spots are intercepts. I don't know if they want you just to give the x values or the ordered If they say ordered points, that's their lingo where you need the parentheses and the x comma y thing, right? They might just say the x values. I don't want to take time to go there. Whatever they want, the intercepts are going to be negative pi, 0, and pi if they just want the x values. If they want like full-on points, then it's negative pi 0, 0, 0, and pi 0. Those are the three intercepts. Okay, final question. Symmetry. This is what I really want to get to. Symmetry. Let's talk about symmetry. Symmetry means same. You know, does it have same some kind of way? Well, let me give you the different kinds of symmetry. X-axis. X-axis. Here's the symmetry kinds. So x-axis symmetry is when it would be a graph like, you know, y equals x squared. It looks that, no, that's y-axis. That's not it. You got to turn it sideways, huh? So like that. Yeah. See how it's the same on the two sides of the x-axis? In other words, the x-axis spears it right through the middle. That's when a graph has x-axis symmetry, if it's the same on the top and the bottom of the x-axis. Same with respect to the x-axis. What is y-axis symmetry? Well, that's the one I just started to draw. That'd be something like this. Anytime a graph is the same on the two sides of the y-axis, right? The y-axis goes through the middle of it. It's the same on the right and the left of the y-axis. Now, the third one is, well, before I go on, does our graph have x-axis? Is it the same top? Let me put the x-axis on there. Is it the same top and bottom of the x-axis? Well, it's similar, but it's got to be identical. Notice this would have to be down here, and it's not. It's got to literally be, flip it over, it's a mirror image exactly there. It's not. It's off a little bit, isn't it? So no x-axis. It's not exactly the same top and bottom. It's the same, but it's moved over, so that doesn't count. So no, this graph does not have x-axis symmetry. Does it have y-axis symmetry? Here's the y-axis. Is it the same on the two sides of the y? Again, no, not exactly. It'd have to be like right here. Then it would be y-axis symmetry, same right and left of the y-axis. So no, doesn't. It's no x, no y. Now the third one it will have, and that's called origin symmetry. That's the trickiest one. That's the one we got right here. Origin symmetry, how can I say this clearly? Two quadrant rotation. Or, you know, I could say it rotation. Or 180 degree rotation. How about that? Just flip it around. That's probably the easiest way to see it. In other words, if you were to take this graph and flip it halfway around, right? Like you take a piece of paper and you just turn it halfway around. If it looks the same after you've done that, looks like you hadn't turned it at all, that's called origin symmetry. So if I was to flip this graph halfway around, this part, you know, would go down to here, wouldn't it? If I flip that thing halfway around, and this part would go up to there. They would replace each. They'd go right on to where each other was, huh? And it would look like I hadn't done anything. That's called origin symmetry. Two quadrant rotation, 180 degree rotation. So this one has origin symmetry. Why they call it origin is because it means if you were to take any point, it's not helpful, but I'll tell you. If you take any point, pick any point you want, like say this point, and you were to shoot through the origin and go the same distance the other side, you'd have that same point over there. It mirrors through the origin. Every point does. Any but this point, mirror it through the origin. There it is over there. This point, mirror it through the origin. There it is over there. Every point is mirrored through the origin. But that's not easy to see. But that's where the name comes from. It's easier just to say, if I flip it halfway around, does it look the same? Yeah. Origin symmetry. Good on that? All right. So, yeah, they give us a whole battery of questions here. They give us this big old function. They're going to ask us a bunch of questions. Question A, they're asking, is that point on the graph? How do you determine if that point is on the graph? Yeah, just plug it in. You just say, okay, remember, this is x, this is y. Hey, f of x is the same as y. You aware of that? Whenever they give you function notation, they say f of x or g of x or h of x. It doesn't matter. That's y. Why is that y? By common agreement. The math science world just agreed. It's not logic there. They just say, hey, functions, those are y. It's common, like, why do you drive on the right side of the road in North America? Well, we've agreed, right? In Europe, they go the other side. It's just common agreement. So functions are y by common agreement. So whenever they say, show you that function, that's your y. So here's I'm going to just write it with y. It's the same as f of x equals. It's y. F of x is always y. Okay, and they're telling me x is negative root 7 and y is 1. So put a 1 in for y. Put the negative root 7 in for x. To the fourth. And then just see if they're equal. If they're equal, it's on the graph. Right? That's the membership requirement for getting to be in the club, on the graph. You make the equation true. Huh. So that point's on the graph. If this is true. Is this true? I have no idea. What's the square root of 7 squared? That'd be 7. It's 14 times 7, right? It removes that root. On the bottom, do you realize that's 49 plus 49? You okay with that? You see that root 7 to the 4th power? Right? Root 7 to the 4th is root 7 4 times. And every 2 of them makes a plane 7. So it's 49, right? So then what is that? I don't know. Oh, 98 over 98. Yeah, that's 1. Hey, it worked. Yeah. So our answer is yes. Yes, it is on the graph. That good? Let's try part B. All right, so part B, if x is 1, what is f of x? Okay. So x is 1, what is f of x equal? Remember what f of x is? Y. So basically say when x is 1, what's y? So just plug in 1. That'll be easy. That's a 1 to the 4th. What's that, 50? 14 over 50, I guess you have to reduce that, huh? Is that 7/25? Y is 7/25. And they say, what point is on the graph? Well, the point 1, 7/25. That's the x and the y. Good on that? Let's keep going. Part C, if f of x is 1, okay. So now they're saying f of x is 1. What does x equal? What point on the graph? So but you do the same kind of thing. This is y is 1. So you take the equation y equals 14x squared over x to the 4th plus 49. And you put a 1 in there. So they're saying y, or f of x, is 1. Solve for x. Ooh. So we got to solve that little equation for x. Can you solve that equation for x? Everybody see what I did, right? I left that f of x be 1. Find the x value that goes with that. How do I solve that equation? What's that? I'd put this over 1, and I would cross multiply. Probably the easiest thing to do. Diagonal, diagonal. So it'd be 1 times x to the 4th plus 49 is 1 times 14x squared. We good so far? Okay, bring it over here. It's going to be x to the 4th. The 1, the 1 doesn't do anything. 14x squared. What now? When you got high powers on x like that, get a 0. Remember all that kind of stuff? I'm going to jump this guy over here to the middle, put him in order. X to the 4th minus 14x squared plus 49 is 0. Factor. That's x squared minus 7, x squared minus 7. Guys tracking with me? That'd be x to the 4th, powers add. Minus 7x squared, minus 7 squared is minus 14. 2 minuses make plus 49. I factored it. And I'm just crazy running out of room here. Then you set each one equal to 0. Well, it's going to be the same thing twice. I'll just do it once. And then move the 7 over. X squared is 7. Take the x squared is 7. What do we do to finish solving that? Put the roof on the house. And when you put the roof on the house, remember my goofy saying? Is it goofy enough? Up and down the ladder. And don't forget the plus or minus when you put a root on both sides. So it's plus or minus, it's still on the screen there, root 7. Those are the answers. Plus or minus root 7 goes with y1. So that suggests 2 points, root 7, 1 and minus root 7, 1 on that. Is that good? What is the domain? We got to keep going. All right, it's a long one. All right, so part D, what is the domain? What did we learn about domain yesterday? 2 trouble spots. Square roots and denominators, right? Inside of a root cannot be, that's the whole, you can't put knives in the toaster thing, right? Domain is allowable inputs. So the domain, you say, are there roots or denominators? Because those are trouble. Yeah, there's a denominator. X to the 4th plus 49. You take the, what do you do when you see a denominator? You say not equal to 0, right? If you have a root, you take the inside and say inside you can't be negative, you got to be greater than or equal to 0. But if you have a denominator, it's a denominator you cannot equal 0 because we can't have 0 on the bottom. How do we solve that? Well, move 49 over. X to the 4th is minus 49. And then root it. What does that mean? Imaginary, so there's no problems. Right? It cannot equal an imaginary number. Okay, great. You can't be imaginary. You can't be imaginary either. You're forced to be real. So it can't be imaginary. So there's no problem. So the domain is everything. It's negative infinity to positive. I don't know if they want interval notation or what they want, but there's interval notation. Does that make sense? Because the domain here, what I'm saying is what it cannot equal. It cannot be imaginary. Well, if you cannot be imaginary, then you can be any real number. Right? Now, everybody knows, here's the mistake I see a lot of times. I'll see that plus 49 equals 0, and people will factor that. They'll go x squared plus 7, x squared plus 7, and they'll try to go on and solve it. That's not true. No. You need to know that's not right algebra. Your algebra skills need to rise. If you're still doing that by the end, it's not going to go well in calculus. That's not true. If you don't know that, check it out. That's not the right factoring. That won't work. Let's go on and try to finish this one at least. X-intercepts. All right, how do we find X-intercepts? Yeah, set y to 0. Remember that? When you want to find intercepts, set the other letter to 0. And so you make y 0. You get 14x squared over x to the 4th plus 49, like that. So I made y 0. And then you solve for x. So how do I solve that equation for x? Do the same thing I did last time. Put it over 1, cross multiply. 0 times x to the 4th plus 49 is 1 times 14x squared. 0 times anything is 0. So 14x squared is 0. Divide by 14. X squared is 0. Do I need to keep fooling around? X is 0, right? I mean, you want to root it? All right, we'll root it. Plus or minus? Yeah. It's 0, right? It's just 0. X is 0. So the intercept then is 0, 0. X is 0, y is 0. On that one. All right, that's it, huh? That's all we got time for. All right, so these 2 sections are due on Monday? Yeah, Monday. All right, have a good weekend, guys. I'll see you Monday. Hang out if you got questions. I'm in this very room for the next 20 minutes.